Okay, AP students, I am so sorry. I cannot believe I had the audio off. Good gracious. That's amazing. I was doing a review, but it was like a 20-minute review or so. So what I was telling you is this. We're almost done with the gas law chapter, but what happens is we have not spring break, we have Thanksgiving break right now. And so what's going to happen is when we come back, we need to have a test in this chapter. Now, there's about there might be 4 or 5 more lessons that don't have any math in it, like just contextual stuff that we'll probably do at some point. 3 or 4 lessons. I'll try. And it'll probably be the end of the week when you come back, not a Friday that you come back after spring break, Thanksgiving break. I'm going to post some extra credit for you. I also might post another thing. I'm thinking of posting another extra credit lessons on writing Lewis dot diagrams. In case you went to UCLA, or if you didn't go, you'll see the videos. Practicing Lewis dot diagrams like H2O is something a skill you need to get in for AP. We're going to do it all next semester. But I like to teach it in this break time so that to kind of get you a head start on it. All right. And anyway, if you want to, and I might even possibly make a little quiz, we'll see, like a quiz when you get back, an optional quiz to help you. There's no math in it. Some of you will love it a lot. I'm sure you'll like it. Some of you that don't, you will like the Lewis diagram stuff. No math. Okay. All right. So for the quiz coming up on this Friday, the most important thing to do is to note that you need to know which equation do you use for which problem. So I uploaded the answer keys right now of all the worksheets. I was doing that as I was talking to you. And so on the answer keys, the good thing is that I show you every single problem. But the bad thing is there's one page of just the PVT equation, for example. You use this on every one of them, combined gas law. Then there's another one where you just use like Dalton's law, like total pressure gas A plus pressure gas B plus pressure gas C. Well, if you knew what I'm going to ask you, yeah, that makes it real simple. It's not as challenging. Like if I'd given you every worksheet and the next day a quiz on just PVT, teach you Dalton's law, then just a quiz on that. PV-NRT, then show you just a quiz on that. That's easy when they're in compartments. But when you put all of them together, that's the only thing that makes the chapter tough. I feel like this is everything I've shown you. In fact, every single thing I've shown you has been, I teach general chemistry, except for, general chemistry does all of this, except they don't do the mole fraction. Like the mole fraction of gas A is the number of moles of A over the total moles, or the pressure of gas A divided by the total pressure in a gas mixture. Let me put that one there. So, I don't give them that, and I don't give them the problem where you have like I'll call it a before and after with PV and RT. Now I'm going to talk about that in a moment. Okay, so what you should do, you should have all these equations written out. Now, I do have a formula sheet. AP gives a formula sheet, and this is the chapter where in class, I give this to everybody right now. I say, okay, I'm going to give you a formula sheet. Use this for your quiz. Well, now, we're distance learning and all that. I can give it to you, but it's interesting because these are on there, but then there are some that are not on there, and there are some that are written in a different form, like Molar Mass, and this one are written in a different form. You won't find that on the AP formula sheet. So you don't have to worry about this right now, but like later in the year, next semester when we review, well, I would tell you, if you see something that's not on the formula sheet, write it down, or maybe add it in red ink or something on your formula sheet, so you'll know I need to memorize that before the AP exam, okay? But that's one of them that is not written exactly like that, and I think it's useful in that form. Okay, so what I was doing on the video today was I was trying to show you first all the equations you need to know, like density is mass over volume, and molar mass. Molar mass is, I just say it's number of grams divided by number of moles. This is true for anything, gas, liquid, or solid. But we'll mainly talk about gases. For any gas, if I know how many grams divided by how many moles are in the sample, I've got the molar mass. That's your density. And of course, I tell you, this is an amazing equation, the meow. the molar mass, you put dirt over, cats put dirt over their pee. Now, this equation, I mentioned it on a video that I gave a quiz one year in an AP class, and one girl in my class, I remember, she used that equation. Like maybe she didn't know what to do or something. She used that on like every problem on the quiz, okay? And she got most of them right, okay? I mean, I'm like, wow. I did not believe it, but yes, it's great. That's how great that equation is. Because what happens is, this is molar mass, this is density. If they ever ask you to find molar mass on a problem, if you read a calculation problem and it says, what is the density of this gas? Use that. Now, if you wanted to rearrange it and make it, you don't have to. I don't do this, but if M equals dRT over P, then that means D would be MP divided by RT. You could rearrange it, but what I do, and I do it in my physics as well, I just say, take the equation, plug in everything you know, and then whatever you don't know, then do the math, like, okay, cross multiply, then divide by that. So however you want to do it. So let me back up and state this again a little bit more clearly. This equation, if you're ever asked, I should put a little green around it, meaning that they don't give you this. If any problem asks you to find molar mass, or if they give you the molar mass, if they ask you to find density or they give you density, then you can use this equation right here. Now, one change you can make to it is this. Let's just say the problem says something about molar mass, but they don't mention density. Well, then I can put M over V, because D is M over V. So instead of D, put in M over V. That's another way to change the Meow equation. Why would you want that? I don't really do it that much, but if you're doing a problem of PV NRT, and they give you the grams, like they say, okay, you got 25 grams of oxygen gas. Find the pressure or whatever. Well, grams you have to change to mole. Well, if they give you 25 grams of a gas and you use this equation, then it kind of has it built in for you. It reminds you, oh yeah, I need the molar mass of say oxygen, molar mass 1602. 16 plus 16 is 32. So I put in molar mass of oxygen. I put in the grams they said, got 25 grams. And then I plug in the others and solve. So some people like this for that kind of problem. I probably wouldn't use it for those myself, but anyway, hey, you guys are the first time doing chemistry and AP chemistry and trying to get through. Show me what can help me. So that could be the magic equation. Now, I'm not going to make any promises, but I'll just say I'm sure that there'll at least be 2 on the quiz on Friday where you'll be able to use that one. There'll at least be 2 of them, okay? Because I know I'm going to do something mentioning molar mass or density. I'm imagining at least, so that those 2 for sure, and maybe some other ones that we'll work on. Okay, so what I also did in the during that video, let me see how much time. Yeah, I'm doing this in between classes, but actually I got a pretty good bit of time. What I also did in the video is this. I worked some problems for you. You probably saw me as I was sitting there going like, talking like that and all excited and telling you this stuff. So I guess some main thing. I'll try to. Okay, let me just go to them right now. Let me go find those problems. I only did like 2 problems, and then I had, what was it? I did like 2 problems, and I just read some others and to kind of let you set it up. So on page 1, I did number 3. I said this is a very good problem. Now, let me mention this as well. Page 1 and the answer key. Answer key says answer key gas laws 5-1. Page 1, 2, and 3. Okay, page 1, 2, and 3, they all use this equation, PVT, PVT. So I would not spend a whole lot of time on that because I'm not going to be asking you a bunch of those. I might ask you 2, 1 or 2 at least, I'd say. But here's what you should know about that. Well, first of all, I did number 3 on page 1. And it said they give you initial pressure, initial volume, initial temperature, final pressure, final volume, final temperature. And so that you're going to find out, is anything constant? And then what would be the gas law you're going to use? Okay, so for this one, I'll look at it. Pressure 1 is 1515 millimeter mercury, and pressure 2 is 1515. So the pressure is constant. So what this tells me, you start off saying, okay, this is a before and after. That's what I call that. If you know here is the pressure of the gas, the volume of the gas, and the temperature of the gas to start off. And here is the final pressure, the final volume. What will be the final temperature? Okay, that might be what they ask you in a problem. Before and after, you're going to use that. Now, when would you not use this in a before and after? If the before and after mentions mole or gram, then you know that you're going to have to, it's going to be the other type where you have to derive it. And I'll come to that in a minute. Okay, so first, I just take PVT, PVT. Number 3, on the first page of the answer key. The initial pressure is the same as the final pressure. So that becomes V over T equals V over T. Then it says, whose gas law is used for this, this one? It will be Charles' law. You should know that volume 1 over volume 2, volume 1 over temperature 1 is equal to volume 2 over temperature 2. You should know that, okay? Now, on the test, when we come after the break and all that, I'll probably have a section where you like match the scientists or whatever, or identify them. But I don't normally do that. I might do 1 or 2 on the quiz, so be ready. Just try to know them. What they do on the AP exam, I've never seen them tell me V1 over T1 equals V2 over T2. Which scientists found this? I've never seen that question in particular asked for the equation. But instead, here's what they put on AP. And you should know this also. They'll say on the AP, which scientist said the volume of a gas is directly proportional to the Kelvin temperature? Or which scientist proved that? Okay, I guess I wouldn't say said it. And then it would say, Boyle, Charles, Gay-Lussac, or would be, what's his name, Einstein, or I don't know, whatever, Graham. Okay. All right, so you might see any of those things like that. So if you saw those, then you should know the scientist. That's Charles. Okay, next thing it says plug in the numbers and then do the math. Okay, so solve for temperature, final temperature. And this, if you look at number 3, you can see that. So I'll just plug them in. The initial pressure, 375. The initial temperature, okay, initial temperature is 195 Celsius. But remember, you got to change it to Kelvin, so you add 273.15. That's another equation they actually give you on the formula sheet. Okay, but you ought to know that one, okay? So add 273.15, that comes 468.2. So as I was talking about this today, I was saying you can look at the answer key and pretty much see it's all on there. If y'all were trying to frantically write it down, then you'd realize now, oh, I already have it, it's all there for me. So I put in the final volume and then find the final temperature. All right, now, here's a couple of notes. Never, never, never put Celsius for any temperature anywhere in this chapter. I think I've told you that. Always put Kelvin. When you see volumes, it's okay if you put in cubic centimeter as long as that one is cubic centimeter. Or it's okay for this to be liter and liter or milliliter and milliliter. That's okay. But now, in PV&RT, the volume must be in liters. Okay, you've seen that. Okay, that's important. Just remember, don't put that in milliliter for that one. Okay, then you, of course, will cross multiply. So 375 times T equals 468 times 585. And the math is there. So it gives you, T2 is 730. Now, if they were to say, what is it in Celsius, then you got to subtract 273.15, and then you get 457. Okay, 457 degrees Celsius. It's on your worksheet, entry. Now, for temperature, I'll just say this as well, that, in a lab, I mentioned this as well in the thing, we measure things in the actual lab in Celsius. We don't ever have a thermometer that says Kelvin on it. Okay, we don't measure volumes. Volumes are always in milliliter or cubic centimeter, milliliter. We don't measure them in liters. That's we don't give you that much gas to produce or to use in a lab. And then pressure is usually in millimeters of mercury. So that even though atmosphere is what we use in the PV&RT. So you can also use that one in PV&RT. All right, so the equation I just showed you, I would do, look at the first page. Can you do the math part of that? Like number 3 I just did was great. All right, then it might also be good for you to work, let me see. On the next worksheet, page 2 of the answer key, I'll just recommend that you do number 2 is very good, and then number 3, actually, just number 1, 2, and 3. I would just say, when you start for the quiz, can you do number 1, 2, and 3 on that worksheet on the answer key page 2? Because that's enough. You don't need to go through all these again. You've been doing a lot of them, and I don't want you to get a false sense because page 1 and 2, all you're doing is using that. That's pretty easy. All right, then I would move on, and if you want to do the other ones, you certainly may. You got them. You can study them. All right, then page 4. Okay, during the video, I didn't go over this very much, but there will be something. Dalton's law of partial pressure. Oh, let me tell you what will not be on it. I'm not going to put Graham's law. That's due tonight. So, in fact, yeah, it can still be due tonight, and I probably won't have anything due tomorrow night, or if I do, it's okay to get to catch up on it later. So everything before today is what it's on. For Dalton's law, you use this total pressure as pressure gas A plus B plus C. So on that worksheet, make sure number 1, that's a pretty easy one. Number 2 is this is a very good worksheet to look at. 2 and 3, gosh. Well, I don't know. 4 is great too. Wow, these are all good. So what could I narrow it down to? It looks like 4. Maybe number 4 looks a little bit better. Yeah. Number 3 and 4. So maybe if you just do number 1 on that page, don't worry about the manometer part. That's more like the multiple choice question. I'm not going to be. But where it says solve the following on the page 4 of the answer key. Number 1, the word problem about what is the total pressure, and then probably number 3 and 4. On the back, make sure you know how to do number 5. Oh no, not number 5, not number 5. Number 6. Number 1 at the bottom. Number 1 on page 5. Page 5, answer key number 1. That was good about the little open up the valve stopcock there. Okay, now also remember for Dalton's law, if you're ever collecting a gas over water, the total pressure is the pressure of the gas plus the pressure of the H2O vapor. That's another thing important to know. Okay. Then, ideal gas law on page 7. These are probably good to go through a lot of them, but for sure, you don't have to do all 1, 2, 3, 4. You don't have to do them all again, but number 1 is good. Number 2 is good. And then I'd say part 2, number 1. Let me talk about that. I mentioned this in the class, in the review, but I didn't do the whole thing. I just said, I read it. You have a compressed cylinder with 500 grams of argon gas at a pressure of 66.7 and 26 degrees Celsius. More argon is added to the cylinder. How many moles were added if the pressure changes to 139.5 atmospheres and 18 degrees Celsius? All right, this is on, again, page 7 of the answer key, and it's problem part 2, number 1. When you read this problem, we're giving you some temperature or pressure before and temperature pressure after. So you might think, oh, before and after, it's this problem. But then it talks about the moles of gas changing. We increase or decrease moles of gas. So if you see that, what you need to do is that you need to derive an equation. Now in the video, here's what I told you. There's a PV nRT before and a PV nRT after. So R is always constant. So R is always equal to PV over NT. Since that's true, then if you, this is true. Now, in all the problems of PVT that we talked about, those scientists, the moles of gas were always constant. It says no gas could escape or enter. But on this problem, there is more gas added. So if you see something about gas being added or gas being released or taken out, or if you see, it's a before and after problem, but you see gram and mole in it. If you see that, well then do this. R is PV over NT. So PV over NT. P1 V1 NT over E1 over T1 is constant. That means it's equal to P2 V2 over N2 T2. So this is really the same law as that. And if you ever went to UCLA AP Readiness And if you went to Mario Martinez's room, he's told me about that. He likes to give his kids that equation and tells them to learn it, because then you don't really need to know that one. It makes it easier. Because in these, mole are constant, so then you have that, then you have it. But on this problem number 3, they give you grams of argon. So, of course, you got to change that into moles. So I'll put in the original moles, change gram to mole. We do that on the problem. You can see the worksheet. Then we plug in the initial pressure and temperature. Of course, the temperature has to be in Kelvin, don't forget. Then it says, well, what's going to be the final number of moles? It says how many moles were added. Okay, N2 is the final number of moles, but it's going to ask how many moles were added if the pressure changes to 139 and 18, Celsius. So you have your temperature and you have your pressure. Now, it also says, well, it should have said this, but a cylinder. It should have said a rigid cylinder. And what that means is the volume is constant. So, P over N1T1 equals P2 over N2T2. You use that for before and after. This, by the way, is a kind of tough one. And it's only come up a few times here, every now and then on AP, like maybe, I don't know, once every 10 or 12 years, they'll pop that in there. So it's not as common. But anyway, I wanted you to see that. PV&RT is. Okay, and then study those I just told you about, and then do some examples about molar mass and density of the gas, okay? The answer keys are in there as well. At least there'll be a problem where I'll say, find the molar mass of the gas, okay? You'd use it. Or find the density of the gas, and you'd use that, okay, if you want to use that one. So, yeah, I mean, what is this? One, if you call that crazy one, 1, 2, 3, 4, 5, 6, 7. There's 7 equations I just pointed to right there. And there might be, I don't know, there might be 6 or 7 on the quiz. So, hey, I'm not telling you for sure you'll use all of them only once, and you might use one more than once. But have this ready, study your best, and I'm sorry about that technical thing. Gosh, that takes the cake of all of them. I've been in class a lot talking, and I'll notice them on the video, but I was sitting there doing this. When I look back, I kept seeing a blank screen of a person, didn't have your screen on. And then at the very end, I saw Destiny. If you've been doing like this, then probably with your video on, I probably would have noticed earlier, but oh well. But anyway, this will hopefully make up for it. I'm sorry about that, you guys. So study the answer key, and like I said, I will put an extra credit up for Chapter 5. When we come back, at the end of the week, we probably have a test on Chapter 5. We're probably going to have only one quiz in this chapter because we need to cover Chapter 6 also. We have 18 chapters to cover in AP Chem, and I've always been able to do it, but this semester we got to get at least to 6, and 6 is shorter than this chapter. So think about 6 will be kind of like the gas law chapter, but shorter and more important, and we're probably going to do it at UCLA on December 12th, I think is the date. Okay. Well, anyway, that's all. I better go. So I better upload this. Got to get to my class. I'm going to be late to my class. I'll see you guys. And and I also might put an extra credit assignment of a Lewis dot diagram if you want to do it. There'll be videos that I made in the spring. I thought, you know what? I'll get them ahead. No math in it. They'll love that. And maybe I'll even give you an optional quiz if I've got time to make it. All right. I'll see you guys. I hope that you do well. I'll see you.